Jack, how are you? Happy Thanksgiving. I know that we'll probably not get this out for a little while, but I think there's some interesting concepts that I'd love your opinion about. So we've just started off talking
Mm,
about the publicly available AI models, the
mm,
private ones, I guess you could call it that, right? The enterprise ones, and then of course the local ones. So if you
mm.
if you had three categories, can we together come up with some guidelines or just some general ideas about what we think? Uh,
Yeah,
these are four. So you were just speaking about monthly fees, and I kept thinking of places like uh, who is Jira and Jira
Atlassian.
Atlassian, thank you.
Mhm,
So there's
mm.
Atlassian, which, and also I used to work with Figma and other and Mural. All of these are like per seat per month charges, right? They tend not to be charges per usage because many people will find that people don't even use the software they pay for, which, having managed software budgets kind of bugs me because some of these tools can be really pricey. I don't think Atlassian's cheap.
Yeah, exactly. Yeah, probably. Yeah,
And Salesforce,
probably.
sorry,
Yeah,
I worked for
yeah.
Salesforce.
Enterprise subscriptions. They are never cheap. Yeah.
Well, but they do operate on this model which works for them, but might not work for some businesses. So if you wanted to get started, I thought maybe you could help introduce your own, which is to do things locally, right? So you can run any sort of meta model, which just means llama. Is that a cute name for something local? La something. I don't know what it
Yeah,
stands for.
yeah. So my experience with local models is actually that I installed a small Mistral model on my local machine, which was probably running on an architecture that is like a good gaming computer that any teenager probably would like to have at home, right? So it's probably a little bit better than a PlayStation 5 kind of system, but nothing crazy. Kind of like a hardware that you can buy in Walmart, on a shelf that says, gaming computers, right, or gaming PCs, right? So kind of maybe mid-range GPU, maybe 16 gigabytes of RAM, that kind of thing. So that model, that Mistral model, was actually interactive. So you were able to talk to it.
Hmm.
It was uh, it was probably performing programming tasks that were quite helpful and was able to write maybe not longer pieces of code, but it was able to maybe look at the code that I submitted and maybe find out a missing comma or semicolon, that kind of thing. So a very very effective tool, running locally. So that was my experience, and I as an engine for question answering, I think that was something that could be considered as an alternative to maybe going to the cloud, to one of the big providers, right? So that was my experience with the small, very small model, right? That kind of fits on a laptop, gaming PC, something like that.
Interesting. So I'll just go in with my HCI axioms here, right? That
Mhm,
humans perceive if things happen instantaneously, that's actually
mhm,
measurable. It is instantaneous. I think it's like a second or something like that. Like we're fine with anything taking that long. And when
mhm,
you talk about performance, one thing in terms of gaming is it makes sense if you can't draw the screen or it's choppy or you can't fire your
mhm,
weapon or whatever the heck
mhm,
you're doing, right? You'll perceive that as being an unpleasant experience, even even if it's technically taxing who knows what. I'm thinking of the cyberpunk game that came out, I guess, a year
mhm,
ago, and everyone had shots of it just not rendering a cutscene or something like that to make fun of
mhm,
it. Hey, you're terrible. Like you're wasting my time, right? So so that doesn't necessarily mean you have underpowered hardware. It could be in a million things, right? In terms of optimization. So I'm only saying that to caveat, like you don't need a top of the line gaming computer if you're willing to wait, or you don't need XYZ, because it will run. I think on most, I guess we call it modern hardware, since GPUs are now either integrated or separate. Anyway, do I make any sense?
Yeah. So I would say yes. I mean, maybe with a distinction that the integrated GPUs probably will not have enough memory to kind of
Right.
run the show. So yeah, so you probably need to have like a mid-range graphical card in your computer. Doesn't have to be a $5,000 card. It could be something that is maybe 500, 600-ish. Maybe like a RTX, GeForce RTX from NVIDIA. Yeah. So yeah, nothing probably out of kind of the mid-range PC off the shelf, right? And there is a lot of good news here that those models that are very small, they are evolving, they are being trained, and they are being evolved into stronger and stronger models. So chances are that the same discussion maybe next year, about maybe the smallest Mistral or the smallest Llama that we will have that we want to install on local PCs will be 10 times more powerful, that they will be a lot more. So those neural networks are being optimized, and that's great and a little scary as well.
Well, which brings up a couple of things, and I'm only saying because you're talking to a Mac guy, right? So I have inline AI processing, and that actually I did read was people at Apple really got into the attention paper, and they're like, well, we just need to optimize this to run this sort of math. And then harkening back, I watched this really great documentary about Half-Life 2, which if you ever watch these gamers, gamer programmers, like, talk about a fascinating world. Like, they literally had to invent everything. And one of the guys there said, well, our thing was so slow because the GPU people were doing the math wrong. They were doing the wrong kind of math. So he said we had to take a couple of years to convince them to change their model, right? So it is interesting that the top of the line gaming laptop may still be not completely optimized for the kind of math that these models might thrive on, I guess, right? I'm not I'm not in that world, but you know what I mean.
Yeah.
Optimization, right? Like you can almost count on it in our industry.
Yeah. And you are talking to recently converted Windows to Linux person. So I just had to switch computers, and after looking at Windows 11, decided that, hey, my primary boot is going to be Linux, and I just
so you're getting closer to having a Mac any day now, right? We'll get you there somehow.
Well, yeah. So that's probably this. Yeah.
Drivers for God's sake must really suck after a while. Like, in any case, but okay, yeah. So yeah, whether we're at Unix as an undercore or Linux or x86, I guess is still Windows. I don't know. I don't know what the heck they write their stuff on, but that's a local model. I will tell you that my very short experience with a local llama to do RAG stuff, the first model that I downloaded, I gave it a problem and it churned on it for ever, I guess. Like it took it a while, and I almost thought it was broken. And then it did come up with something, and then I changed the model. And sort of at random, right? I think these were all llama models, but I changed it to another model and then it was instantaneous. So I don't know. I mean, that's a bad example, but your mileage may vary in terms of what you need. Is that your experience?
Yeah. So very small model on a local computer, on a PC, or maybe even on the phone, right? That is something that requires a little bit of a different attitude in terms of the problem decomposition, which is probably something that you should be doing anyway, right? Like if you want to write a piece of code, or you want to summarize a document, or if you want to maybe create some sort of a technical description of a problem, then it kind of pays to subdivide the problem, decompose the problem in your head into smaller chunks. Or, I know that there's models that are kind of doing this, on the big model side, right? But, if let's say this is for privacy, security, and all the good reasons, if you want to go with something that is like, on your hardware, then probably it's not a huge deal to actually prepare the problem so that it is, decomposed into simple steps, and then you are still taking advantage of all the large language model magic that you can have, without the cost, basically, without the cost and without the security.
Well, this is where we get interesting, right? So now we're going to talk about enterprise. You and I can do whatever we want. We don't have any particular security concerns, although I'm interested in whether or not I have this imaginary idea, which you can laugh, by the way, this is supposed to be a joke. This imaginary idea that all these files that I have and collected over the years and all this work that I've done has something in it that's interesting and useful. Okay. You can laugh because you could also say, no, there is no historical usefulness to all this unstructured data. Now, if I'm going to go into a company, though, most of the people in the company are going to say, hey, we have all this information that we don't use. Let's try to put AI to bear on it so that we can uncover hidden riches. Right? Am I getting close to the dollar signs that get into people's head?
Exactly, yeah. But however, I would modify the assumption. I would actually reverse it. I would say that in the enterprise environment, we have a big discomfort about our data leaving, the intranet and going to the large language model, and we don't want to do that. That could be actually the number one concern that I'm hearing. So we don't want the data to go to a large language model. We are not comfortable with the large language model retaining possibly the outcomes of the processing based on our data, and we are not comfortable with the whole flow, right? So as an enterprise system kind of environment, the large language models deployed somewhere on the cloud, especially maybe for OpenAI, right? Because they are kind of like on the forefront, and they have this interface that everybody's using. So I think the level of discomfort there is probably the highest. Like, hey, they have this very open system that maybe they are not sharing with everything else, but here's the enterprise data, and we don't want it to go there. I think that is the prevailing assumption that maybe we should be making, whereas the one that that there is no concern might be an outlier, maybe for organizations that are maybe special, right? Like it's not going to be a banking organization, right? It's not going to be legal kind of firm, right? They're going to be very secretive, right? So the architecture, right, has to kind of take into account that number one thing. We have to either convince them that the data is safe in flight, that the data is safe in the neural network, and the data is safe after it leaves, and that data is not being reused without our consent, which you don't have, to actually improve the system, right? So I think those would be the prevailing assumptions, in the enterprise world, right? Just kind of like my 3 cents. But we can start with your assumption, because it kind of gives us the intellectual freedom a little bit more.
Well, I don't mind this at all. I'm just saying that the assumption is that we have something of value, okay, which I can say is most probably not true. I don't think you do have anything of value, but let's just say, nobody knows, right? We don't know how operationally useful any of this data may be.
But there is a scenario.
Okay.
Well, there's a scenario, right? So let's say, this is something that I kind of looking a little bit into, like, well, there's people that are leaving, right? An organization, retiring.
Well, I was going to get to that. Like, humans don't matter, but somehow some crap on their hard drive does. You see what I mean?
Yes, and we, yeah.
but
Exactly, and we would like to know what they do, right? I mean, the exit interview that is half an hour is not gonna even scratch the surface.
let's
So
look
there
at their
is,
ticket. How many things did they? Yes, I know. It's all this thing of like, does anyone
yeah,
do anything? Maybe another topic for another day. But the paranoia, I was also going to say the CYA of it all makes sense, right? Nobody wants to be bold, except maybe your boss, our good friend Vince. Maybe Vince has enough confidence or power or whatever to convince that yes, we don't. Well, you're still local though, which is what I was going to get at in a second. Is giving your stuff to bigger models. But why don't we stay local for a second, right? Local could be for paranoia reasons. Makes sense that people can be paranoid, right? Number two, it seems possible to mimic the same results, at least because these models are open source. Again, the open source community kind of also belays the idea that you have something outrageously valuable in your company. that
yeah, absolutely, yes, that's correct. Yes, I
okay.
would say you can go very far with open source models. Yeah.
Okay, so you do have the ability to kind of mitigate your downside by doing things locally, but then you're going to go to your IT department. You're going to say, start to set up all this stuff so that we can do all this mining. And like you just said, they'll all go buy gaming PCs, which would be great because then they can play Fortnite all day long or whatever, right? Like when the things aren't running, which is going to be most of the time because we still have to build an infrastructure around how to utilize knowledge in using these new tools. You see what I mean? Like, I think that's the human part we don't really know, except maybe on an individual basis. And you could tell me that on an individual basis, you find yourself thinking more, coding less, having more time with your family and enjoying life? Or do you feel like you're just 10 times more productive? So your 10-hour workday is just you move mountains of. Sorry, I don't want to call you out because I don't want anyone to be mad at you.
Yeah. So for me personally, I think that the coding was always this kind of like a special activity that you really would love to do, but it's really not like you could write effectively code for 8 to 10 hours a day, right? I mean,
Oh,
maybe there's
exactly.
guys like that, right? So I felt like I can be productive with coding for a few hours during the day, where I'm kind of really kind of not getting tired yet, right? So that was even when I was 21, and kind of in my prime intellectually or whatever, right? It was probably not a very long period, but now with the AI,
Okay, well,
coding
let's just
has turned.
interrupt. We spent all
Yeah.
of our time debugging. Let's just make this clear. Like I wrote too, but most of the time it was fixing something that didn't work. Is that the same with you, or are you a better coder than me?
Yeah, obviously, yes. Well, things happen, especially when you are, when there was like a Windows update that ruined your .NET code or something like that. So there was always a lot of this stuff happening. But with AI being in the loop, now coding has turned into more kind of like a creative activity. It's more like painting. It's more like writing a diagram, for a complicated system. So a programmer kind of is more like an architect right now, and it's so enjoyable that really, maybe that point that you're making, hey, I feel like I can do more. I can spend more time with the code without feeling that I'm kind of burning out, right? So that is kind of maybe suggesting that the new wave of code that is going to be generated is going to be different. It's going to look differently because people can do more, and can do maybe this process more enjoyably, and that is something to think about. And that there is, I think, at the same time, the tools for coding will change, right? I always like like the tools that were in the computer graphics environment. Like, the Unreal Engine, for example, has an Unreal Engine development environment, which is
Oh,
graphical. You build a
oh
graph,
yeah,
right?
yeah.
Right. So maybe tools
Well, it's
for
also the
programming will change.
interface
Yeah.
of chaining. It's a visual metaphor to how you chain events, right? Rather than it being
Yeah.
sort of
Yeah.
an
Yeah.
abstract, calling of methods kind of thing, right? Like where it's a little bit, that you can see things how they encapsulate to make bigger things. Which
Yeah.
I agree. There's a language called uh, Quartz Composer, which was an early Apple thing that also used this, and you could build neural nets in it because that's kind of how they work, right? Like they're just sending chains of things. Anyway, sorry to interrupt.
Yeah. So if typing is now taken care of by large language models, then maybe we don't need to look at the code. Maybe we just need to look at a different representation of code, because anyway, underneath, there is machine code, there is assembly languages that nobody looks at, and we had that interface that was Python or C++ that was kind of like a human readable thing. But if we
Mhm.
don't need the human readable thing, then maybe we need something else, and that something else could be maybe something like a graphical tools that kind of allow us to drag modules, and here are the modules, and make the system out of those. So I think there's going to be revolutionary stuff happening pretty quickly.
I'm going to give you huge props because I do believe, at least in my experience, many, 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 many coders and engineers have no affinity to this higher level thinking. Sorry, I'm not saying that they're not smart. I'm just saying I don't think they are very creative. In fact, I don't think the industries really serve them well because they tend to not get to exercise that. They tend to kind of be pixel pushers or whatever terrible name, I don't know what's the word for it, right? Or just they're thought of as being very low level and not strategic, which I agree I can't support because I think that what they do is incredibly strategic, but that means collaboration probably with more strategic, or I'm a designer, right? So I always
Mm.
wish they talked to the designers because as I mentioned, this Half-Life documentary was like the designers and the engine had to work together perfectly. Like they couldn't go off on their own, and they couldn't just say, "Here's the ticket, write this subroutine." They had to collaborate,
Mm.
which is why I think gaming is probably some of the most influential coding. I don't know what to call it. Like it's very uh, instructive
Yeah.
because it has to work together to be successful, right? It can't
Yeah.
just be the greatest, fastest engine ever. It also has to have depth and it has to have a meaning. It has to have all these elements. So, and perhaps every coder is a gamer, but do you see a disconnect? I'm just curious, especially as in education, you must have had some people that would just not cotton to this that you've worked with.
Yeah, my opinion is that let's I worked quite a bit with in the gaming industry, and these people who wrote code, for games were very stressed out because
Uh,
it's a very deadline driven industry, right? You have to have your product out, for Christmas or whatever, which means that
mhm.
you have to ship it, I don't know, by August or something like that. So programmers often are so deadline driven. They're so tight, in terms of the time that they have, that maybe they don't have time for the big picture. They have to churn out the code in a very high complexity environment, and the teams are huge, and the complexity of the hardware is significant, and there is unexpected things that can happen, right? So yeah, I mean, generally, yeah, I mean, there's not a lot of happy faces in those really high pressure programming environments, and I'm hoping that maybe AI is going to change that, so that it's going to be more like a like a more enjoyable experience for people who have to write very complex systems or design very complex systems. I'm certainly hoping for that, and and so yeah, I have mixed feelings here. I don't know how quickly this can happen, but on the other hand, right, when you look at other areas, other than gaming, and you look at what John Carmack says, for example,
Mhm.
about the code, right? Like how inefficient certain things will be. Like there's drivers, and they will be like a terrible bottlenecks. Like there is going to be one team that spends maybe a lot of time optimizing a neural network, but then there is a driver that is connected to it, and it's really such a bad design that it's really serving as a
Mm.
bottleneck, and there's basically nothing you can do about it. So the whole system is basically slowed down, but by a some inconsequential piece of code that came from somewhere, right?
Mhm.
So if you look at those kind of things, right, and then maybe there's opportunities to really quickly convert those pieces of legacy code into something that neural networks, large language models can quickly optimize and kind of get kind of everything to the next level. So yeah, I think that there's so many sides to the story, but John Carmack, if we want to look at the state of the programming industry, his speeches are kind of going to the heart of it, and sometimes it's not very flattering, to your point.
Yeah, and I saw him speak ages ago. It was great, just because I think he might have actually have had an early version, or at least the what would you call it, the inspiration behind the attention model, right? Like the idea of how do you economize when you are trying to do all these computations by basically ignoring most of the stuff that wasn't important, right? And to stay on
Yeah.
these particular. So it's very important, and part of a thesis for what I'm writing, by the way, is that nature absolutely 100% prioritizes the most efficient way to do anything, right? Like that's the beauty of nature, is to make things as simple and as not necessarily simple, but as direct as possible, right? That is its nature. Whereas, our nature as people is often to make things more complicated for no
Yep.
particular reason other than it justifies our existence sometimes, and well, makes everything complicated, right? And that's sometimes power, right? That you have to go through some method. So I've got these examples here because I was going to say, if you're working all locally because of fear, which is probably the case, right? And then you have a bunch of, let's just say, moderately talented engineers, it's not going to be very difficult sort of to prop these things up if they haven't done it already. What I think is going to be really interesting, and what you and I kind of focus on, is what is the value, right? What's actually going to happen? And you've mentioned a good case, which is that you're not particularly good or interested in spending a lot of time debugging, and I'm not either, right?
Mm.
But I can let somebody else do the work, and I can start to look at the flaws and optimize it to get an outcome that I think might be useful, for whatever project I'm working on. Right now,
Mm.
it might be writing projects, and I'm definitely using Claude to help me with writing projects. And there's nothing I feel like I'm contributing to Claude. I mean, here's the thing. So let's just talk about third party, right? We're worried about using Claude because my particular tokens that I throw at it are going to be really great, and somebody else can look at them and make money off of my idea. I don't know exactly, right? Like this is the idea, or maybe you could express it better. What are people afraid of, and what is the reality of that? Because I don't see these tokens as doing anything but waiting out outcomes. I don't see how you would track them back to say, oh, IBM is planning to take over the Ukraine, or whatever. Like whatever you're feeding it isn't what comes out, right? I mean, it gets digested, and digestion itself is means you can't really put it back into being a piece of celery again. How are my metaphors? You got to correct me on this.
Yeah, so unfortunately you can put you can reverse engineer that, whatever comes, those pieces of information,
Oh, you
those
can make the
those
salary again
activations.
from the
Yeah, so yeah, you can. Yeah, unfortunately, you can, right? So whatever goes to the large language model in the format of those vectors or embeddings is reversible, right? So you can actually use that very same data set for unauthorized training of a different model, which means that somebody might ask a question after the training is completed and kind of like extract maybe proprietary information from the organization that it was interacting prior, before the model was trained. So unfortunately, the security concern is very real, very complex, and even kind of like, again, to the point, like, hey, it's not just about somebody intercepting the data set and storing it somewhere, but it's also about somebody intercepting the data sets, using them for training, and now having a large language model driven ability to process that, summarize it, extract, query, in ways that were not accessible to let's say hackers before. So yeah, so I think that this is a very real concern. Now, there is also opportunities
I was
here,
going to
right?
say, can I ask a follow-up
Yeah,
on this? So this is
sure.
really interesting, and because it seems like also a different business model, for example. So let's say that you subscribe, or your business is subscribed to ChatGPT in order to do general purpose marketing. That's always fun, right? That's pretty public. You don't
Mm.
necessarily have secrets, you're probably not too secretive when it comes to your marketing plans. You try to be public. Is that fair as
Mm.
a example? So
Yep.
how we've got
Mm.
that, and then we've got some output that we can track. Let's just say we have some sort of license, right? Hey, I can see all the output that you have created.
Mm.
However, it might not know the inputs. This is where it gets a little bit weird, because I always think it's the inputs that really do need to be cataloged. This idea of a prompt engineer, right? Somehow
Mm.
that you train your company into best practices around how to prompt to get better outputs, right?
Mm.
That's almost like coaching, like executive coaching. I, for example,
Mm.
went to a class where they told you to always talk with your hands, right? That's a thing. They teach you to say,
Mm.
hey, it's always good. Express yourself with your hands. Anyway. But so here we go. We could say, here are the things that problems you're looking to solve. Let's catalog all those and try to create some understanding around it. Seems like good business, right?
Mm.
Um, but you're saying I can actually take the outputs, forget the inputs, and reverse engineer the inputs?
Yeah. So yes, because the inputs, right? If let's say we have a table that we submitted to to a large language model. We uploaded an Excel table, and that's maybe a table that contains something like revenue model, of a company, right?
Salaries are always the
Yeah,
best thing.
or
Here's
salaries,
everybody's
or
name and
something
everybody's.
very, very, very sensitive, very proprietary, right? So yeah, so that piece now exists within the provider, infrastructure, right, and can be used to train a better model. And in fact, I think that's one of the primary sources for model improvement. I mean, they probably scouted all the data from internet that they already could, and now they are improving the system by looking at of what people are trying to do with those systems. So maybe they are nice, and maybe they are anonymizing and all that stuff, but we cannot assume that. But the fact remains that the input data can be used for training, and whatever comes out at the other end from the large language model after it has been trained can actually look into those input data sets, and can actually maybe retrieve something that is very sensitive, and that's a very real problem, right? So you can go back, right? You can ask a question, hey, what would be a data set that gives me that kind of answer, right? And maybe it will reverse engineer to something that you submitted, right, as a sensitive information. It cannot be ruled out. So yeah, so conversationally we are in a severe danger, in terms of conversational powers to retrieve something very sensitive from a large language model's training.
Yeah, I like your perspective, but I think I fundamentally disagree that humans are actually able to take advantage of any specific knowledge. I'm like, there are very few situations, especially now politically, that any particular knowledge seems suspect in terms of its, like you just said, here's the salaries of all the people or something like that, right? Like that's usually interesting only because it's obscured, right? And there are actually laws now trying to put that there should be some transparency, right? Just because there's no particular reason other than psychological control to keep a lot of this stuff secret. Now, if you talk about, are you going to beat earnings next week? Well, we've been kind of skirting this for quite a while as well, right? Like there's no total veracity to any human knowledge, right? It's all some opinion, and I think I'm reading this book about this now, right? Which is, these are just stories we tell ourselves, right? There's no such thing as truth. I'm sorry that I'm not going to remember the guy's name, but he wrote *Sapiens*. It's his new book anyway, and it's kind of about AI, and yet, as I said, this has a little bit more to do with job security than it does with actual understanding of the way the world works, right? Since we already have this tool that, and you can disagree, and sorry, 2 disagreements with you already, Jack, and you didn't get to yourself. But the other disagreement is, I'm like, well, we taught a machine how to play chess, right? And its goal was to beat a game of chess, and we taught it to play against itself until it got really good at chess. Then we said, okay, here's another realm, which I think was Go. And then here's another realm, the human language. Let's just take English, for example. Play the game of human language. And I was like, well, that's kind of, to me, all it does. It's learn to play the game of human language. And the game of human language is to communicate these ideas, whether they're true or not, but in a way that people would accept them. But there's no truth to them. They're just tokens that get put together, right? Like, anyway, you can talk me off of either of those points.
Yeah, I think I understand your point, but I think, there's also another side to the story, which is, the internal regulations within organizations, right? Like an enterprise.
100%.
Might have rules that simply say no, right? And so those arguments about probabilistic systems really kind of mixing things together and really kind of making it very difficult to kind of retrieve whatever we are talking about here as sensitive data that came into the large language model.
Something that is actually going to hurt your company is likely to be something that isn't really part of this world. You see what I mean? Yeah. We're talking about slight efficiencies, right? And or maybe outsourcing customer service, which I tried to do with my bank. And as we all know, talking to somebody about something is impossible to do anymore, right? They just won't. They won't let you do it. So, but that's a cost saving issue, right? You just don't want to hire as many people to do these sort of random jobs, especially unquantifiable ones. But yes, sorry. Keep going.
But then there is going to be an internal, there's going to be a cybersecurity team, within an enterprise organization, and they will simply say no. Our data is not supposed to leave the enterprise, and that's the end of the story, right? So, and maybe you can convince them, but it's going to take years, maybe, right? And involvement of all the stakeholders and radical change in the company policy, right? This is all. These are all valid concerns.
So is it likely that in industry right now, and I'm not sure that right now your code base was probably built upon just looking at a ton of code, right? I mean, you just need to train it in a lot of code. And I'm not sure how much of that was proprietary, but there's plenty. I mean, you could train it on all of GitHub, I suppose. That's plenty of code, and it would know a lot. That's kind of the genesis for coding models, right? Just like they picked all the Frank Frazetta pictures and trained it how to make art based on that, right? It's this this idea, like you only know what you know, but at least with code, there are free repositories like GitHub that make it fairly easy. You don't need to go in and get the source code for Windows or
Yeah.
whatever, if that's a thing that people care about, right? Compiled
Mm.
code. You get to see the actual code.
Mm.
Am I on base now, right? Like that's how it knows how to code, doesn't it?
Yeah, exactly right. But there's something interesting that can happen, right? Like, for example, we talked about this Jira, system which can be used for project management or planning, right? So the current architecture of that system is that there might be a database somewhere. Maybe it's deployed, locally, or maybe it's not a database, whatever. It's a data structure that kind of holds all the things that appear on screen. That's the Jira interface, right?
Mm-hmm.
Now, with the large language model interface, with the large language model engine, I'm sorry, not the interface, but as an engine, what can happen is that all that traditional design can go away. Because if, let's say, you have a multi-model large language model that understands the screen, the graphics, and the meaning, then you don't really need to retain a database. You don't need to really retain a code base that is the user interface. You can really kind of ask the large language model, hey, I would like to have something that kind of displays like a screen that looks like Jira, but doesn't have to be like that. But I need to do like project management and some planning, on screen. So you will be able to ask a multi-model large language model to actually run a planning software for you, and you will not have all the classical components in there. Everything is going to be just existing in the large language model memory, and it will be just, right now those large language models are just displaying, individual images, right? But there is already talk about the video models like that they can output videos, right? So I think we are really this close, maybe a year or two from the situation where large language models will be displaying user interfaces, and
Yeah.
will be kind of, you will be able to talk to them, you will be able to kind of do the tasks that you want to, and and kind of do the work in a totally new architecture where everything is taken care of by a multi-model large language model, running the interface, doing the processing, storing information in the neural network or whatever you choose, because it will be able to generate SQL for you if you want a database. So that was going to be interesting, and then all the enterprise system vendors, I think they already know that. They are probably a little bit unsure, like, oh my God, this is kind of changing the whole landscape of the entire enterprise software industry, which is like everybody.
Mhm. Well, can I say it already is here? I can't say that it's ready to go, but I'm using a thing called v0.dev. And I'll the companies are paranoid. Makes sense. And they're, in a sense, the people who are most well compensated probably are more paranoid, probably because they're well compensated, right? And on
Yeah.
the bottom, we have